Bright Tuty. Every student matters.
Here is another question now. What is it saying? It is saying list the outcomes you can see in this experiment. See, the experiment word is again used. Spinning a wheel. So first experiment is that you are spinning this wheel. So the arrow mark, or I say the pointer, can stop at any point, right? So we have the outcomes as A. It can stop at B, it can stop at C, it can stop at D, right? Both the A are same, they are identical, right? So somebody may say that there are 5 that they see, but A and A, these are two identical, right? It may stop at this point, or it may stop at this one, like on this one or this one, but yes, the outcome is same. So there are actually 4 outcomes, right? We count different ones, right? If A and A is there, we don't say that there are 5, we say there are 4 only. Okay, so what is the answer? 4 outcomes, right? Now the next part, B, is asking you tossing 2 coins together. If we toss 2 coins together, right, so what are the possible outcomes? Let us list them out. So on both of them, what can happen? On both of them, head can come, right? On both of them, tail can come. On the first one, head can come, and on the second one, tail is coming up. Or on the first one, tail comes, and the second one, there is a head on it. So you see there is 1, 2, 3, 4. Right? So when we toss a coin, head, right? We write it as capital H. That means both the coins are showing head. Then T, both the coins are showing tail. Then we have head, tail. One is showing head, another is showing tail. But in this also we have 2 things. First one shows head, or second one shows head. So tail, head. So these are the 4 possible outcomes if we throw 2 coins together, like, or I toss 2 coins together, right? I may get head and tail. So these are the 4. You can also perform the experiment and you will be receiving these 4, right? You all can have a coin in your hand, 2 coins simultaneously, and try to toss them and list out the outcomes that you get. Clear? Here is another question, right? Here, when a die is thrown, you have to list the outcomes of an event of getting. Just the outcomes we have to list out, not probability. So outcomes only we have to write. So for die, we will write all the 6 first. 1, 2, 3, 4, 5 and 6. These are the 6 possible outcomes, right? Now first one, A part. What is it asking? A prime number. What is a prime number? Do you all remember? You already have done this in your lower classes. So let me revise it. A prime number is the number which is actually divisible by itself, right? Suppose I say and 1. So defining the prime number is a number which is actually divisible by itself and 1, and not any other number. So if we talk of 2, right, 2 is the number divisible by 2 and 1. There is no other number that will divide 2 exactly, right? So 2 is a prime number. We talk of 3 is a prime number. So you're already familiar with it. So out of these 1, 2, 3, 4, 5, 6, and remember, 1 is neither prime, 1 is nor composite. Clear? So we have to write prime number. We know prime is 2, 3, 4 is not a prime number, because for 4 we can divide it by 1, we can divide it by 2, we can divide it by 4. There are more than 2 factors that can divide 4. There are 3. 1 and 4, definitely. Other than that, 2 is also involved in it. So it's not a prime number. So we have 2, we have 3, we have 5 definitely. 6 is not there. 6 is divisible by 1, 2, 3 and then 6, right? So it will not be a prime number. So these are the 3 outcomes if we say event of getting prime number. So these are the 3 possible outcomes for prime. In B part, it is asking not a prime number. The numbers which are not prime are 1, then 4 and 6. These are the 3 numbers which are not prime. The second part, they're asking A, a number greater than 5. So greater than 5, there is only one number, that is 6. And in B part, they're asking a number not greater than 5. Not greater than 5 means less than 5, right? No, it should not be greater than 5. It may be equal to or it may be less than. So we have 1, 2, 3, 4 and 5. These will be the possible outcomes. So I hope this question is clear now. Let's go to the next question. Here is another question. So the first part we are going to concentrate first. It says probability of the pointer stopping on D in question number 1 is, so I have already kept the image for you for this wheel, I say. So they're asking in the first part, probability of the pointer stopping on point D. So naming the part as A, we have to calculate probability stopping pointer at point D, right? So again the same formula, favorable, right, favorable outcomes divided by total outcomes. So how many are in our favor? So first of all, let us calculate the total ones. We calculate total how many? 1, 2, 3, 4, 5. So there are 5. Total is 5. And we have to calculate probability of pointer stopping on D. Out of these 5, how many D's do we have? We have only 1. So it will be 1 upon 5. Right? So this is how we calculate the probability of the pointer stopping at point D. Clear? The second one, it is asking probability of getting an ace from a well shuffled deck of 52 cards. So the cards that we have are 52 in numbers, right? You all might know that we have in that 4 different aces, right? Of a diamond we have, right? Of a club we have, right? Then we have of heart, right? And the last one is, so out of 52 cards, we have 4 different aces, right? We have 4 aces in number. So we have to calculate the probability of getting an ace, right? So total, that the number of aces is 4 and total number of cards is 52. So when we cancel it, 4 ones are 4 and 4 threes are 12. We get 1 upon 13. So this is the probability of getting an ace out of 52 cards, right? So the question was probability of getting an ace from a well shuffled deck of, well shuffled means the cards are randomly mixed with each other, right? The next part is C part. In that they're asking probability of getting a red apple, and we have to see this figure, this one. Okay, so probability of getting a red apple. How many apples do you see in this image? We see that there is 1, 2, 3, 4, 5, 6, 7. Total is 7, right? And how many out of them are red apples? 1, 2, 3. So 3 upon 7. This will be the probability of getting a red apple out of these 7 apples that are there in the figure. I hope this clears more about probability. Here is another question, right? They're saying numbers 1 to 10 are written on 10 separate slips. So numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. These are the 10 numbers written on different slips and kept in a box and mixed well. They are randomly mixed with each other. One slip is chosen at random, okay, without looking into the box. So we have to calculate the probability of getting a number 6. 6 is only 1. So 1 divided by how many of them are? In total, there are 10. 1 upon 10 is the probability of getting the number 6. Getting a number less than 6, right? So 6 is not included in it. Less than 6 we have 1, 2, 3, 4 and 5. So 5 are the number of favorable outcomes. Total is 10. So the probability becomes 1 by 2. The next question is getting a number greater than 6. Here also greater than 6 we are talking. So 6 is not included. So after 6 we have 7, 8, 9, 10. These 4 numbers. And total is 10. So cancelling it with 2, we get 2 upon 5. This is the probability of getting a number greater than 6. Then getting a 1-digit number. So we see out of these 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are only 1 digit. 1, 0, that means 10 is having 2 digits, 1 and 0. These are 2 digits. So we will just take 9 as the favorable one and total are 10. We can't convert it into simplest form. So this is the only answer that we have. Otherwise, we have already converted in other parts in simplest form. Right. So a very easy question was there. Now let us move to the next one. It is saying that if you have a spinning wheel of 3 green sectors, 1 blue sector and 1 red sector. So let us have a rough idea of how that spinning wheel would look like. So this is a spinning wheel and how many sectors? 3 green sectors we have, suppose 1 and 2 and this is the 3. So we have 3 green sectors. We have 1 blue sector. So this is the blue one, and one red sector. So this is the red sector. They're asking what is the probability of getting a green sector. First of all, find out the total one. How many are there in total? 3 green and 1 red and 1 blue. So total are 5. Green sector are how many? 3. So 3 are in our favor. This will be the probability of getting a green sector. The next one, what is the probability of getting a non-blue sector? How many are non-blue? 1, 2, 3, 4. 4 are non-blue out of 5. So 4 upon 5 is the probability of non-blue sector. Clear? So different question also can be formed on the same question, and you definitely can frame the questions yourself and try to attempt the answers, or the questions you can attempt them. Okay, here is next question. They're asking find the probabilities of the event given in question number 2. So the first one is a prime number. So what we will do is first A part. Okay, they're asking a prime number out of 1, 2, 3, 4, 5, 6. We know that total are going to be 6. A prime number, because the event there was, or the experiment was of throwing a die. So these are the possible outcomes. A prime number. Prime number I told you we have already discussed in question number 2. What are the prime numbers out of these? So prime numbers we will write first. Prime numbers are 2, 3 and 5. Total is how many total numbers? Total numbers are 6. So probability of getting a prime number. Getting a prime number, the probability will be how many are there in number? 3, which are prime, divided by total is 6, that is 1 upon 2. B part, not a prime number. How many numbers are there which are not prime? 1 is not prime, 4 is not prime, 6 is not prime. So probability of not a prime number, it will also be 3 upon total is 6, that is 1 upon 2. Now C part, they're asking, or I should say it is second part, first A. So a number greater than 5. How many numbers are there greater than 5 in it? It is only 1, that is 6. There is only one number, right? So probability of getting a number greater than 5, it is only 1 divided by total, that is 6. So 1 upon 6 is the probability. In B part, we have to answer a number not greater than 5. So how many numbers are there which are not greater than 5? We have 1, 2, 3 and 4. So probability of getting a number not greater than 5. How many do we have here? So not greater than 5, that means it should not be greater than 5, but it can be equal to. So we have 1, 2, 3, 4 and 5 is also included. So 5 divided by 6. This will give us the probability of a number not greater than 5. So I hope this question gives you more clear idea about probability. So this is all about probability. We have done different questions. So these are the only kind of question that are asked in exam. The question can be on number of balls. The question can be on a die. The question can be on 2 coins that we toss, right? So there are multiple questions that can be formed, multiple real life examples that can be taken. And suppose I have a class of 30 students. The last example that I would like to give you. Suppose we have I am the in charge of class 8th. Okay, and I have 30 students in my class. So now randomly the chances of asking a student a question, right? So I can ask any question out of any student a question out of the 30 students, right? I can ask any one student the question. So what is the chance of a student getting the chance of answering it? So that is, there can be only one student that I will be asking randomly at once. So 1 upon 30 will give you the chance, right? So that's all for today, and thank you so much, and do watch the videos attentively, and stay tuned for more videos. More upcoming videos are coming up, and there are there are a lot of interesting chapters that are coming up. So we have a great content to show you and explain you. So stay tuned. Thank you so much.